we talk about iterated integrals. As far as the precise definition, fundamental theorem of calculus definition, a double integral, that's difficult. This right here is what we're talking about, right? That's like I said, from the definition, limit definition, or whatever, it's difficult to do. But if we think of it as two separate integrals, which are the iterated integrals, it turns out it's not that bad. I mean, it can get hairy, but it's not that bad. Okay? For example, one of the integrals here, if we're talking about, again, R is the region X is between A to B, Y is between C and D. That's our region R. Then here's what we can think. We can think of the integral from C to D of fxy dy. We can think of that as one of the pieces here, and that would be holding x fixed, because we're integrating with respect to y, holding x fixed in our function, and then integrating with respect to y. Okay? So it's the partial integration, if you will, similar to the partial differentiation. We're just integrating that with respect to y. Well, if we do that, what that gives me is some function of x. A function of x. Because if you think about it, this is a function in x and y, and if we integrate with respect to y, that's going to give me something in terms of x. If I'm holding x fixed, it gives me something in terms of x. So what I can do then is take the result of that and integrate that. So let's say now we're integrating with respect to x. So I take that and integrate it with respect to x from A to B. And essentially then that's a double integral, because this right here is this, right? It's the integral from C to D f of x, y. So you see I've kind of got a setup going here where I have a double integral. It turns out it's pretty well that nice. So all right. Now, of course, that's how we evaluate it. How they write it, though, is typically they'll just write this as integral A to B, integral C to D, f of x, y. But this shows you how you do it. You just do the integral with respect to y, first of all. Take that integral, and then you integrate again with respect to x. Similarly, we could flip things around. We could do the integral from C to D, then the integral from A to B, f of x, y. So now I'm going in the x first, right? So I've got dx first and then dy. But it's evaluated similarly. Do the integral C to D of the integral from A to B. Okay? So it's not that bad. Yes. Now, it does turn out an important result here is that if f of x, y is continuous on the A to B, C to D for x and y, turns out they are equal. Okay. That's an important result. It's called Fubini's theorem. Fubini's theorem says if fxy is continuous on r equals a to b by c to d region, then our volume double integral thing is equal to the integral a to b integral c to d. And it also equals the integral c to d integral a to b f of xy dx dy. Okay. Okay. So yes, sometimes it may be easier to do the x first, then the y. Sometimes it might be easier to do the y than the x, but it turns out those are very much the same. Okay. All right, so let's do a couple of those and see do a couple of things. All right, so let's evaluate double integral over r 4x minus y dA. R is 0 to 2. All right. So this would be equal to then, if it's like this, we have our choice. And it doesn't, looks like the x and the y are just about the same as far as complication there. So I don't think it's going to matter. So let's do the x's first. So 0 to 2 and then 0 to 1. Minus x minus y. The x's endpoints listed first. So I'm going to do with respect to x. Then I'll take that result and do the derivative with respect to y. Integral with respect to y. That secondly. First, right? So the y is fixed here. Of course, 4 is a constant. The y is fixed, so y is a constant in this context here. So that would be 4x minus 1/2 x squared. And then y is just like 4, so for xy. Respect to y. Okay, so from 0 to 2, we've got 0 to 1. So we've got 8 minus half of 4, so 2 minus plug in the 0, they think everything's 0. So this is just 6 minus 2y. With respect to y then. Y squared, 0 to 1. Now we're going to respect to y, so it's 6y. Y squared now. 0 to 1. 1 0 to 0. Be 5.